All right, so the next thing in our notes is going to be to solve quadratic equations. So there's one property here that we're going to utilize a lot, and that's called the zero product property. The zero product property is very, very simple. It just says that if you're multiplying two things, so if I take like A times B, if I'm multiplying two things and it equals 0, take something times something and it equals 0, then that must mean that one of the things that you multiplied by has to be 0. There's no other way around it, because that's how a zero product works. So in other words, if you had an equation that was like this, right here, if you had an equation that was x plus 3 times x minus 4, and we knew that that equaled 0, then we could utilize that zero product property, or really just common sense here, to say, okay, well, that must mean that this thing right here, this x plus 3, has to equal 0, or that means that this x plus 4, or x minus 4, has to be 0. But one of them has to be 0, because we're multiplying these two things together, and the answer is 0. So we can basically set up these two situations, set them both equal to 0, and say one of these has to be true. And there's two little equations then that we can solve, because if I subtract 3, I can get x equals negative 3 now, or I can get x equals 4. So this is the zero product property, and we're going to use that to solve equations. So in our next example, it says find the roots, or you really could just put in this problem, just solve the quadratic equation. And since it equals 0, right, we're going to use the zero product property. We're first going to factor this. We're going to take the left-hand side, and we're going to try to factor it. If we can factor it, then we can then solve it after that. But first we want to see if it's factorable. So I look at this left-hand side, and I'm going to try to construct it with two parentheses. So I have something times something equals 0. So we go back to what we've been doing this whole time. We want to think about, can this be factored, right? So think about the snowflake method, and we say that the a value is 1 and 1. The c value, or the a times c value, is negative 42. And the middle term, the b value, is negative 1. So we think about, is there something that multiplies up to this top? Can we multiply to get to negative 42? And at the same time, can those two things be adding to negative 1? If you think about that, there is one, right? Because we have, I know that 6 times 7 is equal to 42. And if I make one of those negative, specifically the 7 negative, then 6 times negative 7 is negative 42, and 6 plus negative 7 is negative 1. So yes, this can be factored, and here is the factoring these two columns right there. So therefore, when I put my answer in, I'm going to put 1x plus 6 and 1x minus 7 now equals 0. Okay, so we factored this. Now how do we solve it? Okay, because the problem doesn't say to just factor, it says to solve, or in this case, find the roots. Kind of means the same thing in this case. Well, we're going to use the zero product property, because now we have a situation where I have something times another something, and it equals 0. So what that means is that one of these things has to be 0. So I take one of the factors, x plus 6, and I set it equal to 0. And I take the other factor here, x minus 7, and I set that equal to 0, because these are my two possibilities. Now each one of these I can solve individually, right? So if I solve this one, I get x equals negative 6. There's one of my answers. My other answer is going to be x equals 7. So all in all, what we've done here is we started with a problem that says solve this. Which x value could I plug in there to make this equation true was the original question. And the way that we did it was we factored it, if it can be factored, which we could do it here, and then we use the zero product property to then figure out the answer. So if I plugged in -6 or if I plugged in 7 into this problem, it would make it true. So there are two answers to that problem. So I have -6 and 7. All right, so practice problem here B. It's a little bit different because this is not in standard form here. You're going to notice we have a quadratic equation, but one thing you're going to notice is that it's not equal to 0 like the other one was. And so that's what we want to put it into. We want to get everything to one side so that it equals 0. So to prep this problem, I'm going to go ahead and subtract 2x to both sides. I'm also going to get rid of this -4, so I'm going to add 4 to this side, and thus I'm going to add 4 to this side to first get it into standard form. So if I go ahead and do that, I'm going to end up with x squared plus 3x minus 28 equals, and now I got rid of all the stuff on the right, that equals 0. So that's the first step of this problem, is put it into, collect your terms and put it into standard form before you even begin anything else, right? Because then we can go from there. Now what we want to do is we want to try to solve this. And the way that we've been doing it is we're going to try to see if it's factorable. We're going to factor it, and then we can use the zero product property. So at this point, if you want to practice, you can give it a pause and see if you can solve it from here. Otherwise, follow along and continue. So this right here, we're asking the question, can I factor this into parentheses and have it equal to 0? So I'm going to go ahead and do my work over here. Snowflake method. I got my a value as 1 and 1. A times c is -28, and then the bottom is 3. And so I know it can be factored if I can multiply by -28 and also add to 3. So what multiplies up to -28? There's several things there, but I'm going to go with that 7. I know 7 times 4 is 28. I want to make it negative. So I'm going to make the 4 negative, right? Because I want to add up to 3 here. So 7 plus -4 is 3, but 7 times -4 is also -28. Both of them are working. Therefore, this does factor, and my answer are these two columns here, which is 1x plus 7 and 1x minus 4. So we factored it, and then we want to go ahead and solve this problem. So we're going to take each individual parentheses and set it equal to 0. So I have x plus 7 equals 0, one possibility. Or I have x minus 4 equals 0. And I can solve each one of those individually. So this first one right here, that means that x is -7. And over here, I get x equals 4. So those are my two answers. Okay, and example 4, it's really just the same problem as example 3, but here's a different way to phrase the problem, and that is find the zeros. Find the zeros of this parabola, right? In 4.1 and 4.2, we were graphing these parabolas. And remember, a parabola can have zeros, which means the parabola hits the x-axis. The y value is 0 there. So if I were to say find the zeros here, basically all I'm going to do is plug in 0 for y. Right? I'm going to plug in 0 for y. And just thinking about terminology from 4.1 and 4.2, all I'm trying to do is take this standard form and put it into intercept form, right? That's kind of what we're doing here. We're changing the form, we're changing the look of what that expression is. So if I want to solve this, again, I'm going to try to factor this. I'm going to take this, I'm going to see if I can factor this right-hand side now into two parentheses. I'm going to go ahead and see if it's factorable. by doing the snowflake method. So this is 1 and 1. A times C is negative 28, and the bottom one is 3. And so what has to work there? What multiplies up to negative 28 and adds up to 3? And this is I just realized this is the exact same problem as the one we did before, right? So 7 and 4, right? It's the same thing. 7 and 4. We're going to make 4 negative. And there's my factoring, right? So it's the same problem. Find the zeros. If I factor that, I get x plus 7, and I get x minus 4. That is equal to 0. So the zeros of this problem is negative 7 and x equals 4. If you want to give the next one another try, if you need another practice problem, here it is. Go ahead, find the zeros of y equals x squared minus 4x plus 4. All right, so answer here, you would set y equal to 0. You would try to factor this, which it is factorable, because I'm going to have 1 and 1 here. I'm going to have 4, negative 4. Think about what multiplies up to 4, but adds up to negative 4. That's going to be negative 2 and negative 2. Negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. So I factor this to x minus 2 and another x minus 2. So that's how I factor that. And then if I want to solve it, then I set x minus 2 equal to 0, and I also set the other x minus 2 equal to 0, which of course is going to give me the same answer. So this is going to give me x equals 2, and the other one gives me the same answer. So there's really just one answer here, and that is x equals 2.